In this video, you will learn how to solve different problems in thermochemistry that involves heat energy, latent heat of fusion, and latent heat of vaporization. Alright, let's solve this problem here. So we're given the heat of fusion, this one, heat of fusion of gold, or the latent heat of fusion. So what is heat of fusion or latent heat of fusion? It is the quantity of heat necessary to change 1 gram of a solid to a liquid with no temperature change. So heat of fusion is from solid to a liquid. And the heat of fusion of gold here is given as 63.7 joules per grams. And it's also given the heat of vaporization of gold, which is equal to 1697 joules per gram. When we say heat of vaporization, it is the amount of heat needed to turn 1 gram of a liquid into a vapor without a rise in the temperature of the liquid. So fusion, this is from solid to liquid. Then vaporization, this is from liquid to vapor or gas. And then we have the specific heat of gold, which is equal to 0.130 joules per grams per degree Celsius. Cp here, P, stands for pressure. So this is the specific heat of gold in constant pressure, which means this is the amount of heat required to increase temperature by 1 degree Celsius when heat is given at constant temperature. All right, so let's solve this problem. How much energy is needed to melt 56 grams of gold at its melting point? All right, so to melt gold, so gold is solid, and then we need to melt it. That means it turns to liquid. Therefore, we use the heat of the value of the heat of fusion of gold. Now to solve this, we use the formula in solving for the energy, which is equal to Q. Q equals the latent heat of fusion, or the heat of fusion, times the mass. So we just plug in everything. The heat of fusion is 63.7 joules per gram, then times the mass, which is 56 grams. Then this cancels out. It will be 63.7 times 56. That would give us 3,567.2 joules. So this is the amount of energy needed to melt 56 grams of gold at its melting point. Right, let's solve this one, the next problem. How much energy is needed to condense 0.123 kilograms of gold vapor? So this means to condense, that would be from liquid to vapor, so we will use the heat of vaporization of gold. So the same formula, heat equals the latent heat of vaporization times the mass, given mass. So the mass given here is in kilograms, so we need to convert kilograms, 0.123 kilogram to grams. So we just multiply this by 1000 grams because there are 1000 grams in 1 kilogram. This would give us 123 grams of gold vapor, and then we plug in all the values given. we have the heat of vaporization of gold, which is 1697 joules per gram, times 123 grams. So this would give us 208,731 joules. All right. What mass of gold will absorb 9.378 kilojoules of energy while the temperature changes from 15 degrees Celsius to 178 degrees Celsius? All right, since we are given here the amount of energy and the temperature change, we can use the formula in solving for the amount of heat gained or lost by a certain sample. In this case, we have gold as our sample. So we use Q equals mc delta T, where Q is the energy, M is the mass, C is the specific heat, and delta T is the temperature change. And we are asked to solve for the mass of gold. So we can derive this equation to solve for the mass. Then this would become Q over C delta T. And then we plug in all the given values. So the heat is given as 9.378 kilojoules. The energy divided by the specific heat. So specific heat of gold is given as 0.130 joules per gram per degree Celsius. And then times the temperature change, that is 178 minus 15 degrees Celsius. Since the energy here is given in kilojoules, we need to convert this into joules. 1 kilojoule is equal to 1000 joules. So this is just equivalent to 9,378 joules. Right. And then the joule unit cancels out, as well as the Celsius, and then we are left with grams for the unit of mass. So that would be 9,378 divided by 0.130 times 178 minus 15. This is 163 grams. And this would give us a calculator. 442.57 grams. So this is the mass of gold that will absorb 9.378 kilojoules of energy, while the temperature changes from 15 degrees Celsius to 178 degrees Celsius. If the specific heat of gold is determined to be 0.185 joules per gram per degree Celsius, during a laboratory investigation, calculate the percent error of this value. So how do we calculate the percent error? So this is just equal to the measured value minus the accepted or the true value divided by the true value times 100%, or experimental minus the accepted value divided by the accepted value. So in the problem, we're given the measured experimental value, which is equal to 0.185 joules per gram per degree Celsius. And the accepted value is this one, 0.130. So we just plug in all the values here, 0.185 joules per gram minus 0.130 divided by 0.130 times 100%. And this would give us a percent error that is equal to 42.31%.